So here we have a kind of subsection of solving equations that we're doing in class, and they're going to be called literal equations. I'm going to start you off with a simple example, and we'll just move into what they really are. You are used to solving something like this. X plus 2 equals 9. You know we subtract 2 from both sides. X is therefore 7. We only have one variable and the others are constant terms. Over here we've changed it a little bit. I've replaced the 2 by a y. But I still want to solve for x. I want to get x on its own, isolate the variable term. So what would we try and do? We would try and subtract y from both sides. So you're going to do that. You are going to subtract y from both sides. And we're going to have x is equal to 9 minus y. Remember that we can't actually subtract y literally from 9 because we don't know the value of y. But we will write the expression that x is 9 minus y. So we've got two variables, but we can still solve for one of them. Down here, we've got no numbers at all. We've got x plus y equals z. But we know we want to solve for x. So we know we need to subtract y from both sides. So we'll do that, and we'll have x is z minus y. So sometimes there's just going to be no numbers involved. But were the solving steps the same as with numbers? Sure. We're going to be using inverse operations. We only used one here just as the kind of the lead into this subject, but we might be using addition, multiplication, division. So these are literal equations, these two, because they have more than one variable. And that's what a literal equation is. So let's do some more examples. Here's the general idea. Here are our solving steps. We want to isolate our variable term and then isolate our variable, just like we do when we're solving regular multi-step equations. Don't let the preponderance of variables get in the way. Just do exactly as you would normally do. So here we've got one, 3a plus b equals c. And after it says, it indicates what we would like you to solve it for. We'd like you to solve it for a. We want to get a on its own. So in our normal world, if we had numbers, what would we do? We'd first of all subtract b from both sides. So we would have 3a equals c minus b. And then what would we do? We would need to divide out the 3, wouldn't we? So we'll divide out the 3. And we have our final answer, solving for a equals c minus b over 3. So it kind of looks a little messy because we don't actually really do much simplifying as we're going along. We can't do any division of numbers. But this represents all of our inverse operations. So we'll go on to number 5. D plus 8 over 5 equals E, and we need to solve for D. What would be the first step? We would want to get rid of that divide by 5. So we'll multiply both sides by 5. So that would give us that D plus 8 equals 5E. Now we're close to getting D on its own. We just need to subtract out the 8, and we will have that D equals 5E minus 8. And we're all set. Number 6, EF minus 3 equals G, and we want to solve for F. So F is here. So first of all, wouldn't we add 3 to both sides? So we will have EF equals G plus 3. And then if we want to get F on its own, we need to divide out that E. So we'll divide out the E. Make sure when we're dividing on both sides, you have to divide each term. And I can represent that by that. So that will cancel out, and we will have F equals G plus 3 all over E. Our final example, I haven't indicated what we want to solve it for. What should we solve it for? Let's solve it for, n, actually. So we want to get n on its own. Well, I will first of all, we want to get rid of this. So let's do subtract m over 3. Subtract m over 3. So we'll have that negative n equals 4 minus m over 3. So we've got negative n. We need to solve for positive n. So we've learned that we can just change the sign of every term. So we will have that positive n equals negative 4 plus m over 3. And we might actually in some cases rewrite that as m over 3 minus 4. Same thing. So these are examples of just regular equations that we might stumble across as we're solving some various things. But I'll tell you what you will often see this used for. Formulas. If you think of circumference formulas, area formulas, perimeter formulas, density formulas, all sorts of formulas, there's many times many variables involved. So formulas are examples of literal equations, and they will often need to be rearranged. For example, here we've got the area formula for a rectangle. And let's say I give you the area and challenge you, I give you the area and I give you the length and I ask you to find the width. Well, I know that in your head you can find the width, but what would it look like algebraically? I want to solve for W. To get W on its own, I need to divide out L. So W is area divided by the length. Straightforward and obvious. Sometimes we might find it's not quite so straightforward and obvious, so we still need to use our solving techniques, isolating the variable term and then isolating the variable. Here's a perimeter formula, again for a rectangle. And maybe this time I want to solve for L, for length. I've given you the perimeter and I've given you the width, and you need to solve what is the length. So, first of all, I want to get the variable term on its own. So I'm going to subtract 2W from both sides. So the perimeter minus twice the width is equal to twice the length. Well, if that's equal to twice the length, to get the regular length, I will obviously need to divide out 2 from both sides. So the length is equal to perimeter minus 2 times the width all over 2. Now we could write that a little differently. We could write that as perimeter divided by 2 minus the width. You can see that I'm applying this divide by 2 to each term individually. So length is cut the perimeter in half and subtract out the width, and that will give you the length. Number 10. Whoops, I don't want to do that really. Number 10. This is actually the formula for calculating your typing speed, which I can tell you mine would be very low. And it's all about how many words you can type, how many errors you make, and how many minutes it takes you to do it. And if you do this formula, it will tell you your typing speed. Well, let's pretend I know my speed, I know my words, I know my minutes. I need to find how many errors were made. So I need to solve this for E. Well, we've got quite a lot of undoing to do here. You notice the first thing we need to do is to, I would say, multiply both sides by m to get rid of any division. So we'll multiply both sides by m. So that will cancel that. So ms is equal to w minus 10e. We're there. Well, we're not there. We're closer there. Let's subtract out the w. So ms minus w equals negative 10e. So now we need to divide out by the negative 10, don't we? So when we do that, we have that. I'm just going to borrow some room from here. The error, the number of errors would be the number of minutes you take multiplied with your speed, subtract the words that you typed, all divided by negative 10. So that's how we kind of delve back into a formula and rearrange it for something else. All we have done is using our regular solving equation techniques, nothing else. It just, some people get a little hung up with all of those variables that we have to keep in place. And the last one is the trickiest one, because we're solving for a variable that is below the fraction bar. And if you're dividing by a number, we don't have like an inverse operation for divide by. Well, we do. I don't know quite why I said that. We would, I can't undo it by dividing by. I can't get d out the way. I guess that's what I'm trying to get across. I could get d on its own by multiplying both sides by t. But how do I get t on its own? Well, we have to do this one in 2 stages. We're actually going to get rid of the division problem to start with. It's not going to give us our answer yet, but it will help us. I'm going to multiply both sides by t. So I've got it from underneath the fraction bar. So I have that RT is equal to d. This, by the way, is rate equals distance divided by time. So a frequent formula we might use. So now I can solve for t, because now I'm going to divide out the r. So time is distance divided by your rate, or your speed. And I want you to compare it with the original one we had. Rate is distance over time. When we have the variable that we're trying to solve for underneath the fraction bar, like we have here, I want you to notice what's happened. These two have just traded places. The distance stayed in the same place, but after we did our two-step operation here, we ended up just trading places. The t and the r traded places. So that's interesting. And I think there might be a practice one that you could try a similar technique with. So this is what it looks like when we're rearranging formulas, which really is quite a frequent thing. And the last one is a board of practice questions. So we've got 8 practice questions. We've started off with the formulas because I kind of ended on the formulas. And then it goes back to just kind of random ones that we might stumble across just in a regular algebra class. So have a go at these, and we will get back together on this to see how you did.